All right, in this video, we're going to look at position versus time graphs, and we're going to start with a simple situation. Let's imagine this point here. We're going to measure everything from this x. So let's say somebody was standing here, and this is 5 meters away from that position x. And let's say this person wasn't doing anything. Let's say they were just standing perfectly still. What would this look like on a graph? So in other words, if I have time here and position here, at time 0, how far away are they from x? In this case, they're 5 meters away. So if I plot this, they would be here. At time 0, they are 5 meters away. And let's just say they sat there and they didn't move. So 1 second later, they're still 5 meters away. In 2 seconds, they're still 5 meters. In 3 seconds, they're still 5 meters. So they're just standing there. They're not going anywhere. So if we were to graph that, what would that look like? Well, if they're still 5 meters away every second, they're just standing there, the graph's going to look something like this. And if we made a line, them standing perfectly still would look like this as a line. This is somebody standing 5 meters away from the origin, what we call it. And if I had somebody else standing, let's say I had somebody standing here, and let's say this was 7 meters away, and they weren't moving, so they would be here, and again, if they weren't moving, they would look like this on a position versus time graph. So their position is unchanged as time passes. So how do we know that they're not moving? Well, as we saw, their position is not changing, but another way that we know is we calculate the slope of this line. So slope, you may recall from geometry, is the rise over the run, how much the graph goes up divided by how much it moves. And so we can calculate the slope between any 2 points. So between here and here, how much does it go up? It goes up none. So its slope will be 0 divided by, in this case, the difference is 3. Doesn't really matter, the point is 0. So bottom line is if you have a slope of 0, it represents somebody not moving. The red line here has a slope of 0. The blue line has a slope of 0. So in this particular instance, nobody is moving. If you're moving, you're going to have a slope, and we're going to look at that next. Okay, so let's do another example. And so we're going to have, once again, this origin here. And let's say somebody started off at the origin and they started moving. And they started moving this way, and we plotted their distance versus time, or position versus time. So at time 0, they're at the origin. And let's say 1 second later, they're a meter away. So after 1 second, they're here. And after another second, they're another meter away, and so on. So at time 2, they're 2 meters away. At time 3, they're 3 meters away, and so on. So if we plotted that, it would look something like this. So unlike before, where the slope was totally flat, in this case, the person is moving. And the way we can figure out how fast they're moving is we can calculate the slope. So pick any 2 points on this line. Let's say I pick this point and this point, and calculate the slope, the rise over the run. So this goes up 3, so the rise is 3 meters, and it goes over 3, and this is seconds, so it goes over 3 seconds. So 3 meters divided by 3 seconds gives you 1, and the units stay as meters per second, which makes sense because meters per second is a velocity. So bottom line, the slope of a position versus time graph, and you can get it from the units, is the y divided by the x, so meters per second. So this person has a velocity of 1 meter per second because every time they go, a second goes by, they move a meter. Now let's say somebody else was also moving, and their distance, their position versus time graph looked like this. Let's say they started at 0, 0 as well, but they moved a little bit faster. So 1 second later, they actually were here, and then they were here. And so that means in 1 second, they're 2 meters away. In 2 seconds, they're 4 meters away. So their graph's going to look something like this. So they're also moving. But if we calculate their slope would go up 2 and over 1. So their velocity is going to be 2 meters per second. So what do we understand from this? Bottom line is that if you look at a position versus time graph, steeper lines represent somebody moving faster. So this person in red, they are traveling in 1 second, they're going 2 meters, whereas in blue, they've only traveled 1 meter. And so somebody moving even faster might look like this. It's really steep. So the steeper the line, this is the takeaway here, steeper lines on a position versus time graph mean that you're going faster. All right, let's look at one more thing on a position versus time graph. So in those examples, if this was the origin, everyone was moving to the right. So what would happen instead if somebody were standing over here and they were moving closer to the origin? So in that situation, they have time and we have position. Let's say they start off 8 meters away. So they're not starting at this point we're measuring from. So if they start 8 meters away, that's going to be here on the graph. And let's say that 1 second later, they're here, which is 7 meters away. And then another second later, they're 6 meters away. And so if we plot this, it would look something like this. And so this is also a person moving 1 meter per second. The difference is if we calculate the slope of this, their slope is going to be, so again, pick any 2 points on the line. They go down 2 meters, so their slope is -2 meters, and they go over 2 seconds, so they get -1 meter per second. So their velocity is -1 meter per second. The negative just means that they're traveling to the left rather than the right. So the negative, that's all it means. The velocity, it tells you the direction they're traveling. Now their speed is still 1 meter per second because the speed, you ignore any negative signs. So somebody traveling to the right looks like this, whereas someone traveling to the left has a negative slope. These two are traveling at the exact same speed though, because every one they go up, it's 1 over. So the slopes are the same. Well, they're the same, just opposite signs. So your speed is your slope, or at least the absolute value of your slope, what we'll say. You can't have negative numbers. Whereas your velocity, which includes direction, is just straight up your slope. So if you have a negative velocity, we typically think of that as moving to the left. Sometimes we think of it as moving down, but it's in the negative direction. So anyway, that's the general idea of how position versus time graphs work. We're going to do some more with this later, but start with that and see how that goes. All right, until next time, I am Jarek Genova. Have a delightful day.